Try this right now, wherever you are. Find something metal, a spoon, a doorknob, a zipper. Touch it. Notice how cold it feels. Now touch something wooden nearby. A table, a chair, a cutting board. Both objects have been sitting in the same room, at the same temperature, for the same amount of time. One feels noticeably colder than the other. But here's the thing, they are the exact same temperature. Both are room temperature. Neither one is actually colder. Your brain just lied to you. And it does it every single day without you ever noticing. This is the story of one of the most elegant and misunderstood tricks your nervous system plays on you. And understanding it will change how you think about the word cold forever. To understand what's happening, we need to separate two concepts that our brains constantly mix up: temperature and heat transfer. Temperature is a measurement. It tells you how much thermal energy a substance contains. Heat transfer is a process. It describes how quickly thermal energy moves from one thing to another. Your skin doesn't actually detect temperature. That's the critical insight here. Your skin contains thermoreceptors, nerve endings that detect changes in your own skin temperature. They don't have a built-in thermometer. They don't measure the object you're touching. They measure what happens to you when you touch it. When you touch a metal spoon, the metal rapidly conducts heat away from your hand. Your skin temperature drops quickly. Your thermoreceptors fire signals to your brain. Something cold is happening. Your brain interprets this as, that object is cold. When you touch a wooden cutting board, wood is a terrible conductor of heat. It pulls heat from your hand very slowly, barely at all, comparatively. Your skin temperature barely changes. Your thermoreceptors barely fire. Your brain interprets this as, that object is warm, or at least not cold. Same room temperature. Completely different thermal experience. One object is draining your heat aggressively. The other is leaving your heat mostly intact. Scientists measure this property, how quickly a material conducts heat, using a value called thermal conductivity. The unit is watts per meter per Kelvin, but the actual numbers are less important than the relationships between them. Copper, one of the most thermally conductive metals used in everyday life, has a thermal conductivity of roughly 400 watts per meter Kelvin. Aluminum, which is in your soda cans and kitchen pans, sits around 200. Steel, your cutlery, your appliances, is around 50. Wood, depending on the type, would sit somewhere between 0.1 and 0.4. That is not a small difference. That is a difference of hundreds of times. Metal conducts heat away from your hand somewhere between 100 and 1,000 times faster than wood does. This is also why walking barefoot on a tile bathroom floor feels punishingly cold, while walking on a bathroom rug feels comfortable, even though both surfaces are the same temperature. The tile conducts heat away from your feet rapidly. The rug, made of fibers with low thermal conductivity, barely does. This principle has real engineering consequences. The handles of cookware are deliberately made from materials with low thermal conductivity: wood, silicone, rubber, plastic, specifically to prevent this rapid heat transfer from burning your hand. The pot itself is metal to conduct heat from the flame to the food. The handle is an insulator to protect the cook. Now here's the part that most physics explanations leave out. Why does your brain work this way? Why didn't evolution give us thermoreceptors that simply measure actual object temperature? Because actual object temperature is almost never what matters for survival. If you step on ice, the danger isn't that the ice is at 0 degrees Celsius. The danger is that the ice is rapidly draining heat from your foot tissue, potentially leading to frostbite and cell death. What your nervous system needs to know is not the temperature of the external object. It needs to know the rate at which your body is losing heat to that object. That's exactly what your thermoreceptors measure. They're not temperature gauges. They're heat loss rate detectors. And in an evolutionary context, that is far more useful information. The sensation of cold is really your nervous system saying, "Warning, you are losing heat to your environment." The sensation of warm is saying, "You are gaining heat from your environment." Neither sensation is a measurement of external temperature. Both are measurements of what is currently happening to you. So the next time you touch a cold metal railing in the morning and flinch at the chill, remember what's actually happening. That railing isn't cold. It's aggressive. It's stealing your warmth faster than the wooden fence right next to it. Both are the same temperature. One is just a far more efficient thief. Your nervous system evolved to detect theft, not temperature. And every time you feel that familiar cold shock of touching metal, what you're feeling isn't a property of the metal. You're feeling a property of yourself, your heat, being rapidly borrowed by the most ancient, elegant, and invisible law in physics. Heat always flows from warm to cold. Your body is warm. Metal is efficient. And your brain, making sense of it all in a fraction of a second, calls it cold. It's not wrong. It's just not telling you the whole story.